are joined here in this episode, the second episode of the course. As you see, this one we made in the first episode. We just made a cube with basic cube mesh, filter, mesh renderer, and a material on it. In this, it should look about the same in the actual viewer. However, the cube will all be made by code. So, without further ado, let's begin. Okay, let's just make a new folder. Let's name this scripts. Let's go create C# script. I'm going to make two scripts. First one is Voxel data. Voxel data. And the second one is called chunk. Voxel data, we're not going to assign to the block. What voxel data is a static class. When we'll make it a static class, and that holds all the info for the locations of different vertices and so on and so forth, stuff like that. The chunk, however, let's just drag on the block, is actually going to be used on the block and it's not going to be static. And if you want, let's just remove the cube mesh filter, but we'll keep the material on it as they'll be used later. So without further ado, let's begin. The first script I'm going to edit is the voxel data script. Let's just delete the start and update and remove mono behavior, so it won't install from mono behavior. And let's also make this a public static class. There we go. In here, we need to make a public static method. Static read only, and there's a vector3 array. 3, and that's the square brackets after our type is it means it's an array. It's going to be called voxel verts, and it's going to have the locations of all the different vertices. Is equal to new vector3 square brackets 8, and that's going to be how many vertices in a cube. Okay, in here I'm just going to show you all the different calculations. These are all the different positions of a cube, which is 1 meter. And by the way, if is just the short for float. So which one of these is a float? Okay, and by the way, I forgot the semicolon at the end. Let's make another one. It's a public static read only, and this is going to be an int. Okay, and in the square brackets I'm going to have a comma. It's called voxel tries. And it's basically going to be all the different positions of the triangles in the cube. So, which is equal to new int, and for now we'll put in 1,6. So later on, when we have 6 different faces, right now I'm just doing 1, it will be 6,6. But let's just make it 1,6 just for now. Okay, don't forget the semicolon at the end. And there we go. Now, I'm going to show you the positions of all the tries in the top face. As you see, there's it. 3, 7, 2, 2, 7, 6. And that's all for the top face. And that should, when we run it and write the chunk script, which will actually render it, give us a triangle. Okay, I'm in our chunk script. Let's just delete all our methods. And let's make 2 variables. It's a mesh renderer and a mesh filter. The mesh renderer, what it does is the mesh filter, which actually has the mesh, will tell the renderer what to actually render in our scene. The filter is what the mesh actually is. Let's actually make a start method now. You don't have to make it private because just leaving it will automatically make it private. In here, let's have an int, and there's going to be a vertex index. Okay, which is currently equal to 0. Okay, basically this will add to a list all the different vertices in which we're going to print out. So I'm making 2 lists. The first one is a vector3 list called vertices. Second one is an integer list called triangles. These are both going to be important when we actually render the mesh. I'm going to make a for loop, and it'll just basically carry on infinitely until these until this is not equal to the length, which we're going to make 6. So if I is greater than 6, it will stop running this for loop, which makes sense because currently it's 0, it's going to plus 1 each time this runs, and when it gets greater than 6, it will stop. Okay, in here we're going to have int triangle index, triangle index is equal to voxel data. We're accessing our voxel data dot voxel tries. As you remember here, this is our voxel tries. Okay, and 0, I. Make sure you have I in there, which is this I. Okay, let's add a semicolon. Then we go vertices dot add. Add is basically when you're adding stuff into a list. We add some component in a list. Let's add a voxel data dot voxel verts. And let's make the index because a vector 3 array triangle index. Good. Then let's go triangles dot add. Okay, there's going to be voxel data dot voxel verts. Sorry, I actually got the little wrong. It's vertex index in here. Good. Okay, then let's go vert index and plus that. Plus is basically same as plus equals by 1. So it's just adding by 1, or if you want to minus it, it would be minus. So it would be minus if you want to minus it. So plus there, and this will make sure we're doing a new vertex every single time. And of course, there, as you see, it kind of makes sense here. Okay, so we're going to be finishing this part of this video quite soon, where we should just have one face floating. Let's just go mesh, capital M, and not mesh filter, mesh, let's call it mesh, is equal to new mesh. Okay, so in we go, open close brackets and semicolon. Okay, now we have assigned our mesh. We need to add this is our custom mesh. We're going to set to our game mesh in Unity. So let's go mesh dot vertices is equal to vertices, which is equal to vertices dot to array. So I'll just explain this when I've done. So mesh dot vertices, this is our custom mesh dot vertices, is equal to these vertices which you just made dot to array, which just converts it. We're going to do much the same thing with the triangles though. I can actually just copy this to save time. And with our custom mesh dot triangles, okay, triangles, and basically we're just saying the triangles and the vertices. Okay, we want to do one more thing, which is mesh dot recalculate normals. The reason why I'm doing that is because Unity does a thing called backface culling. The reason why they're doing that, by the way, I'll explain what backface culling is in a sec, but the reason why I do that is for performance. Basically, you need to know normals. Basically, normals are like this little stick they're facing on one side. Let's say a plane, and normals are this little stick facing the top, let's say. If it's facing the top, if you look at it from the bottom view, it will look invisible. But from the top, you can see it. So it's only one, it's about half the rendering amount that you need. And now just recalculate them all outside. Let's go to our mesh filter where we can set our filter dot mesh, which is our custom, which is our mesh filters mesh is equal to our custom mesh. And there we go. I just noticed a little problem here. I don't know why I did that. Okay. And there, now we can go to Unity. And if I'm correct, what should happen is we just choose our block in here. Let's just assign a mesh renderer. make sure you actually have these components here. Okay, it's just dragging a block right there. And what should happen is when you press play and stay in scene, there we go. Oh, and I'll actually show you normals right now. As you see, it looks completely invisible. If we look at it from the top view though, then as you see there it is, right there. And as you see, the normal is facing upwards. Okay, so now I've made one little plane at the top. Now I set it up so we can have the entire cube, which is actually easier than it looks. Okay, I'm in Voxel data now. I just need to write down all our different faces quick. There we go, and let's just make this 6, 6. We actually need to do one more thing. If we, as you see, if our texture was black, our plane was black at the top, even though that the texture we had was this little pixely arrow. The reason why is because we haven't made our own UVs, which is basically how the texture is projected onto a object. Usually isn't a problem with Unity because it's, if you have a cube, let's say, it's all auto UV'd, but because this isn't auto UV'd and we all made it ourselves, then we must actually do it by hand and set it by hand. So let's make a public static read only. There's a vector2 array. It's called Voxel UVs, which is equal to new vector2 and 6. There we go. And that's the locations of UVs. Okay, and this is what you should get. And there we go. As you see here, we have all 1, 2, 3, 4, 5, 6 different values here of the different faces. It's basically a 2D version of what we made over here. Oh, and I forgot to add a semicolon there. Good. Okay, now it's nearing the end of the video. I just need to do a few more stuff. First, we need to make a vector2 called UVs. There we go. I actually need to make another for loop. It goes through the vertex to add triangles to the list. It's basically the same as this. It's just called P. Okay, and let's just close it. And it's a cool thing in Visual Studio Code. I'm not sure if it's in other programs. Just select the entire thing and click Tab. It's a pity it doesn't work for delete though. Okay, so if we go there, as you see now we have it. For loops, changed it to P, and we can change from 0 to P. Okay. We must also go uvs.add in here. Before we add the vertex index, uvs.add, we're adding, okay, it's still a list. Voxel data, voxel UVs we just made, and with array number I. Okay, and the final thing we must do is down here, we must do another one for UVs is equal to UVs.toArray. Okay, I'm in Unity. If we press play now, very scene, as you see, it looks pretty much identical to what we had. However, this cube is entirely made of code. Well, at least the code created the mesh for the cube. This is the end of the episode. I hope you enjoyed it. Bye!